This chapter 9 out of this green book that we're going to start today, what it's on, the whole chapter, is called conic sections. Okay? So, what do you think conic sections means? Sections of cones. Like, it's really what it is. So, basically, if you take a cone and you cut it a bunch of different ways, you get different shapes depending on the angle in which you cut it. So if you take a cone and you cut it on like a little bit of a diagonal, you get what's called an ellipse. A lot of it, looks like an oval, but mathematically we call it an ellipse. Okay? So, in this chapter we're going to talk about ellipses. We're going to find all the important characteristics of ellipses, how they're used, and all that kind of stuff. If you cut it perfectly square, like parallel to the bottom, you would get a circle. So again, we will talk about circles and all the important characteristics and the equations of circles and all that stuff. If you cut it on a little bit of an angle, a little bit steeper of an angle, you get what we call what's that shape called? Parabola. So we're going to talk about parabolas and all their different uses and how they, work and the reflective properties and the equations. And then the weird one that you actually need two cones to see the full, and you kind of stack them on their tips like this. If you cut it perfectly straight down that way, kind of off-centered, well, what you get is you get two shapes. Yes, there's one that's like that in here. Yeah. So if you take two cones like this and you cut it perfectly square, you get what looks like two opposing parabolas, but they're actually not parabolas. Okay? They kind of look like two opposing parabolas, but we actually call those hyperbolas because they're actually a little bit different. They act different. They work a little bit different. So they're not the same thing. They have slight differences. And basically this chapter, what we're going to do is we're going to talk about those four: ellipses, circles, parabolas, hyperbolas. We got to know the equations of them all. We got to know how to graph, like take the equation and draw the graphs. We got to be able to label all the important characteristics of them. Talk about where we see them, how we use them kind of in real life type of applications. And then also the reverse of that. So if I can give you some important characteristics, we should be able to write the equations as well. Okay. The order in which we're going to do these doesn't officially matter, but we're just going to kind of go with the order the book picked, which is we're going to do parabolas first, circles second, ellipses third, and then fourth hyperbolas. And then the way this book is set up, what we're going to do is after we talk about all four of those, we're going to talk about them in their simplest form first. Basically, we're going to center everything at 0, 0. Put everything at the origin. Look at basic circles centered at the origin. Look at basic parabolas centered at the origin, and so on. And then after we kind of talk about all those, then we'll talk about, all right, now we got to shift them all. And instead of having a circle at 0, 0, well, what's it look like when we put a circle kind of up in a different quadrant? Put it up in the second quadrant or third quadrant or something like that. And we'll kind of move them up, down, left, and right. And we'll do all four of those at once. That's kind of the basic idea of what this whole chapter is on. This isn't you're going to find this chapter both easy and very difficult at the same time, which is really weird. Okay? The weird thing is, when we talk about parabolas, you're going to go, parabolas are easy. I got this. Oh, I know all the important characteristics. This is easy. And then we're going to talk about circles, and you're going to think the exact same thing. Oh, circles are easy. I can do these for days. No big deal. What was that parabola? Oh, yeah, I kind of got that. Okay, and then we're going to do ellipses. And you go, oh, ellipses are easy. They work kind of similar to circles, which makes sense because they're kind of circular, but they're stretched out circles. And then, but they're also kind of similar to parabolas because, you know, they're kind of have some similar characteristics. And then, but they're easy, and I can do those. And you go, how do you do parabolas again? Totally forgot how to do that. The hard part is there's so many little pieces to each puzzle. The hard part is keeping all the individual pieces straight. It's just that there's so many little things, and parabolas have their own little characteristics and how you find them. None of it's hard. It's actually really easy to find all the important characteristics of all of them. But knowing the important characteristics of the parabola and keeping those different than the important characteristics of the ellipses and how you find those, and the circles, and then you got hyperbolas, and there's a lot of little pieces to each puzzle. Again, I don't think anything in this chapter mathematically is difficult. You're going to find it all, as we go, very easy. The hard part is keeping them all straight. Like not mixing up the hyperbolas and the parabolas, and not mixing up the ellipses and this, you know, circles, and it's just that part of it can be difficult. So when people ask me, is this an easy or a hard chapter? Well, it's kind of both. It really is. You know, you're going to find this chapter really easy as we go through it. But then you have to retain stuff. Like that's really where it comes down to. So make sure you're kind of taking good notes so that you can keep things straight. Even when we're doing it, you're going, oh, this stuff is easy. Make sure you have good notes, otherwise you're going to start mixing things up. And that's when people really start to struggle with this stuff, okay? There's some prerequisites. I'm going to skip the first section because the first section, I think, is all super, super easy stuff that we've already talked about. So everybody take a look at, no, actually I want you just to go to page 614. If you look at page 614, this first section, these are all things I already expect you to know how to do. Distance formula, midpoint formula, find the equation of a line. These are basic skills that we're going to use this chapter. So they're things that you're going to have to already know how to do. You know, basically, throughout this chapter, there's going to be times where you're going to need to find the distance between 2 points. That could be just as simple, you know, when we talk about circles, you know, we're going to talk about where the center point is, so you're going to have some sort of point.
Excuse this interruption. The internet for Chromebook should be back online. If you hit that link for this hour or next hour, you should be good to go.
I mean, we all kind of already know that one of the most important characteristics of a circle is going to be its radius, right? Well, there might be a time in this chapter where I give you the center point and I give you a point on the circle, and your job is you got to, you know, first find the radius. Well, what's the easiest way to do that? Distance formula, right? So you're going to need the distance formula throughout the chapter just as we work on these. You're going to need midpoint formula because maybe instead of these two, I give you, you know, I'll say on one end of a diameter, here's a point. On the other end of the diameter, here's the other point. Why would you need to know the midpoint? Well, that's the center of my circle, right? So throughout this chapter, again, there's going to be some prerequisite stuff. I don't think with you guys I need to spend time and give you homework on using the distance formula, doing the midpoint formula. Here, you know, find the equation of a line. I don't think we need to do that. If you do, then we'll spend some time. But basically what I want you guys to do real quick, look at page 617. I'm not going to assign anything on page 617, but this would be the homework of that section. The first few problems, just find the distance between 2 points. I think that's easy. Yes? Does anyone need me to review the distance formula? Cool. Also midpoint. Find the midpoint between those 2 points. I think you guys are good with those. 22 through 30 would be just an exercise in the distance formula. They give you 3 points, and you got to find out, is it an isosceles triangle, equilateral triangle, or a scalene triangle? Well, you would just have to find the distance of all 3 sides, right? Distance formula, distance formula, distance formula. If 2 of them are the same, it's isosceles. Easy? Again, I think it'd be a waste of time to go through those. One basic Algebra 1 skill that I do need you guys to be able to do is find the equation of a line, like y equals mx plus b. Take 2 points, find the slope, be able to put a point in for x and y, solve for b. You guys remember doing that a whole bunch back in Algebra 1? Again, if we need to review that, please let me know, but otherwise I'm basically just going to skip this stuff. Okay? Any comments, questions, concerns on this? Cool. So today I'm actually going to start parabolas. We're not going to get into too much. I'm actually not going to assign any homework yet today. But basically I want to talk about parabolas. One of the coolest things about parabolas is we use parabolas on a daily basis. We really do. We don't realize we're using parabolas on a daily basis, but they're really useful things. I'll bet you every single person on a daily basis in this room, just about, uses at least 2 parabolas every single day of their life. Every day. I know I use at least 2 every single day. Well, one of them is on my car. Anybody know where there's a parabola on my car? Huh? It's in the headlights. There's a parabola in your headlights. The reason why there's a parabola in your headlights is parabolas have a really, really useful reflective property. Could you, if you wanted a headlight, could you just put a light bulb on the hood of your car? Would that work? No, it would be absolutely awful. You wouldn't be able to see a thing. Why? When a light bulb goes off, which way do the light rays go? Every single direction. So yes, there is, this is kind of a bad color. I need a different yellow. Oh, those are some really bad yellows. All right, I'll do the black background.
I like it.
All right, hold on. I can do this. Hold on. We're going to change everything to white. All right. Now, why couldn't you put a light bulb on the hood of your car like that? Because yes, light is going to go where you want it, but it's also going to go up in the sky, which is completely wasted energy, and it's also going to come back into your eyes and blind you. So you actually won't be able to see anything. So the first thing you have to do is you have to block the light rays that come back to you. Well, that's easy enough to do. We can do that by simply moving the light bulb. And we'll put the light bulb on the hood of your car, right? Looks like Rudolph's car now. Oh my gosh. I'll fix the car. Okay. Now, is that going to do well? The answer is no, because it's still sending light rays in every single direction. Yes, the car is blocking them, which helps to solve the lights in the eye problem, but do we really want to send light this way? No, that's just wasted energy. We want to use that energy. It's going to lighten it up, but it's not going to light it up very well, right? And it's also going to send light rays straight down. Do we really need to light up this area right in front of the car? No. So parabolas have this reflective property where here's a parabola, okay? Parabolas have what are called a focus point, okay? And then they also have what's known as a directrix, okay? These are the two real important parts of a parabola. There's also what we call a vertex. Now the vertex right now is not going to be that important to us because the vertex right now we're going to just put at 0, 0. So that's going to be pretty easy. But one of the cool reflective properties of parabolas is if anything leaves the focus point, okay? If anything leaves that point and it hits the parabola, it gets reflected. Now it doesn't just get reflected out, it gets reflected out in a straight line. Okay? So all of those would be moving not only out away from the car, but why would this actually be helpful? Well, I'll magnify. So here's my parabolic mirror, right? They make a mirror out of a parabola. Where do you think they actually put the light bulb? Right here at the focus point, right? Now, not only does it reflect all of the light rays going out, but it does something even better. It takes all those light rays and it actually focuses all of that energy into one nice, tight beam of light, right? Now, why is that important for headlights? Because now I can have a little bit of energy. I don't have to create a giant amount of energy to make a super bright light, right? And I can focus all of that energy going out exactly where I want, and I can aim that and I can put it exactly where I want to focus that energy, right? I can even focus it so much that it doesn't go into the eyes of the oncoming driver, right? I can turn it where it's just a little bit down, where in my car, so draw another car. How's that, better? Okay. So now my light rays are all going to be focused in one spot, basically. And I can focus that as much as I want. Now, there is one more problem, though, with just this design. Again, if this is my mirror, and I put my light bulb right here, yes, this light ray is going where I want it. This light ray is going where I want it. This light ray is going where I want it. But what about that one? Is that going where I want it to go? No. So we want to capture that one too. Why waste the energy? Why waste any light rays? So they put another mirror in front. So it'll be a double reflector. So, yeah, we'll talk about more of those tomorrow.